Welcome back. This is a series of 3 lessons about tree traversal. There are 2 forms of tree traversal, so we'll talk about one of these forms, which is called breadth first traversal. In this lesson, we'll think about what traversal is, how breadth first traversal of a tree works, and how to answer exam questions that might come up. First of all, what is traversal? We can traverse any data structure, and what traversing a data structure means is visiting every node in the data structure. We mustn't miss any out. We've also got to make sure that we don't visit any node more than once. This is useful for a wide range of processing tasks. I'll just give you one example. Supposing you had a data structure that stored all your customers' details and you wanted to send an email to every customer. You wouldn't want to miss any of the customers out, but you wouldn't want to send any of the customers more than one email. So traversal works for any kind of process like that. And we can traverse any data structure, not just a binary search tree, but the examples that I'm going to include are binary search tree examples. There are 2 ways of traversing a tree. They're called breadth first and depth first traversal, and I'm going to talk in this lesson about breadth first traversal. In breadth first traversal, we start at the top of the tree and just read the levels down one by one. And within a level, we read from left to right, just like we would when we're reading the words on a page. So it's a very natural form of traversal. So here's a very simple example. If you were given this tree and you had to visit the nodes in order using breadth first traversal, it would go like this. Start with the root node 7. Then go to level 1, 2, 9. And then as you go down each level, visit the nodes from left to right, 1, 5, 14. So a complete breadth first traversal of this tree would go 7, 2, 9, 1, 5, 14. Yes, it really is as simple as that. Here's a more complex example, but because the tree has been written neatly, it's very, very easy to do it. So the answer would be 10, 8, 11, 2, 14, 1, 6, 13, 16, 4, 3, 5. We're going down each level one at a time, and then at a level we read across the page from left to right. If you had to do this with a tree that was written in an untidy way, you might have to check carefully what the different levels were. And remember that all the nodes at a particular level have the same number of links back to the root node. So 2 and 14 are at the same level because they're both exactly 2 links away from the root node. However, if you're careful and you write your trees neatly, it almost takes care of itself. Here's another example. You try it. Bit of paper, get a pen, write down the order in which you would visit these nodes if you were completing a breadth first traversal. Stop the video. I'm going to show you the answer in a moment. So there's the answer. I won't read it all out. Fairly straightforward. Hope you made that work. That's probably a bit more complicated than you'd see in the exam, but if you can do this one, you can do any. Remember, they won't always be numbers. You could see letters or words, and it may not be a binary search tree. It may not even be a binary tree. I have seen examples in the exam which are not binary trees, but it doesn't matter. You just do the same thing read each level from left to right. They might ask you to describe in words what a breadth first traversal is. Basically, we start at the root node, we visit each level going down from the top, and at each level we go from left to right, and we stop obviously when we reach the bottom of the tree. Pretty easy. Of course, breadth first traversal isn't the only way to visit all the nodes in a tree, but sometimes it's the ideal method to use, particularly if you have an application where you want to start at the top of a tree and work your way down, looking at each level, starting with the upper levels, and review all the items that are at a particular level. So, for example, supposing you were going to write a program to play a computer game, and you wanted to start with a particular move. You always began at a particular doorway, for instance, and then you wanted to review all the moves at each level before you went on to the next level. So you might organize your all the possible moves of the game using a tree structure, and then allow the user to see the next moves by using a breadth first traversal. Programming a breadth first traversal is quite straightforward. We use a print queue. We could just, for instance, if we're doing it in Python, use a list and decide to work it as a queue. We'd enqueue the root node, so now the queue's got one item in it. And then we'll loop while the queue has any nodes in it. So until the queue completely runs out of nodes, we loop. What happens inside each loop? Well, we take off the front node of the queue. We take it off the queue, so the queue goes down by one. We print the data in that node, but then we add both its child nodes to the queue. We can find them because of the pointers. So we follow the pointers, find the two child nodes and add them to the print queue. So you can see the print queue starts getting bigger and bigger because each time round the loop, we're taking one item off and adding two items. So the queue keeps getting bigger and bigger and bigger until we get to the bottom of the tree where we start to reach the leaf nodes. And at that point, we're dequeuing the nodes and they don't have any children, so we're not adding anything to the queue. So at the bottom of the tree, the queue starts to get smaller and smaller until every item has been dequeued and we've printed out the data from every item in the tree. So here's some final practice. First things first, write out the breadth first traversal of this tree. Fairly straightforward. And if you want to, try to program a breadth first traversal. Add it to the programming that you've already done. If you haven't started doing any programming yet, then that's your stretch task. However, in lesson 3 of this series, I will take you step by step through writing the breadth first traversal procedure for a binary search tree. Okay, in the next lesson, I'll tell you about the next type of traversal, which is called a depth first traversal, and that one starts at the bottom and works up.